So you started a question and we went somewhere. Partly it is solved. So your question was, suppose this is a full bridge.
That is far away.
Yeah, whether this technique is valid.
Yes.
Correct. Yeah. Maybe I'll redraw because it's a. Maybe this time I will draw a full bridge.
So I suppose that doesn't matter, right? If it's a full bridge or quarter bridge or whatever, you're measuring the difference in the two arms.
Yes. As long as we are not loading those output terminals of the bridge is happy. So this will be R naught into 1 plus or minus kx. This will be R naught into 1 minus or plus kx. Yeah, this is what we expected for a cantilever with 4 strain gauges. Some load cell will also be discussed like this. So now let's see the point that you mentioned. The measurement system is far. So that means I have wires from here that will have lead resistance. Even this ground will have some lead resistance. So I'm going to apply this, let's say, Vs here. Bridge is going to draw some current. So there will be some voltage drop in this RL1 and RL2. So my actual bridge voltage will be lower than Vs. Voltage drop there. So I'm thinking, okay, I've applied Vs. I got some output voltage. But it's now more correct. So definitely there is a problem. Now the other point is, now since we learned this voltmeter, instrumentation amplifier, we will use that. Because we know simple voltmeter is a problem. Now I will use this. This also has got lead wire resistance, let's say RL3 and RL4. But good thing is, there is no current here. Yes, because high input impedance. Same here. So due to that, this one actually, there is no problem. Whatever you get here will be available with an amplification factor and delay load.
So those
RL3 and RL4
doesn't matter.
Will not have an effect, but RL2 and RL1 will affect. So we need to have some way. So what we have done in the last class is we injected a current.
And yet the two probes connect.
Correct. So when I injected current through Rx, I know if Kx is 0, I have I into Rx. Sorry, I into R0. Now it's a bridge with 4 resistors. I don't know whether, the voltage that I get across this, is it something easily calculable? I don't. Because if I send a current of I into equivalent resistance by this will be the voltage here.
But then if it's push-pull, then it should change accordingly, right?
Correct. So that's the point. Okay. So let me look at that. So if Kx is 0, let's see. Let's say Kx is 0. That means these two branches together, it will be 2 R naught. Similarly, these two together, 2 R naught. They are in parallel. So the equivalent resistance will be R naught. So that is across, let's say, maybe P and Q. Now, if there is Kx, actually you said, see, there is plus or minus Kx and minus or plus Kx. So, in series, they get cancelled. Same in the other side. So, that way, actually, the full bridge always give an equivalent resistance across PQ as R naught. Right. So, the bridge excitation voltage Vs will be I into R naught. So, we can say output voltage will be I into R naught multiplied by plus or minus Kx. Yes, because earlier we have seen, it was Vs into plus or minus Kx was the output for the full bridge. Vs is now replaced by I into R. I phi n has a gain, that will also come. Let's say that gain is G, then it will be G times. So the instrumentation amplifier INA, yes, if that has a gain.
Which it will have, right?
Yeah. You can have unity gain also, because if it's a 1 plus 2 R by Rg, correct, no? The unity gain may be not possible. For that, R has to be very, very, very low. This has to go to 0, correct? Yeah. So, anyway, you have an INA set again.
Well, INRs have linked together when we can choose one and 100. I forget now.
Yeah. So, 1 plus, maybe 1 plus, what was the equation? 1 plus 2 R by Rg. Suppose if Rg is not there, open, then it will be 1 plus 2 R. But then its state is there. If Rg is 0, then also there is a problem.
If Rg is very large,
then that's what open circuit. Rg is infinite, then
they'll stop.
Correct. Correct. So if I think I missed that.
You said 0.
Yeah,
is 0.
Correct. That's, yeah. So if Rg is infinite, then this goes to 0.
Then no.
Correct. Exactly. So that is possible. Unity gain is possible. So INA, gain by the INA G, I into R naught is the bridge voltage, plus or minus Kx is the parameter that we want to measure.
So we have a question. Why would someone use a unity gain? In what situation? Wouldn't you want a higher jet value? Or does that have something the limits of a circuit that you're measuring?
See, actually, unity gain, for example, this configuration, this is unity gain.
Yes.
Because it is R by R. So, 1. So, here we have utilized its common mode rejection property alone. Okay. So, it depends on the case, right? Correct? also depends on what is your stage following this. If you have sufficient voltage already to give it to the next stage, you don't make it bigger than what the next stage can accept, and then various factors like that. So, okay, so far we are good. But one thing what I don't know is, see, I mark like this, but how do I realize this?
But how can you?
Again, it just says I, but how? Will it just like that come?
The current source there, no?
Yeah, current source, but how is it really generated? Now let's say there is a current that I am injecting. In that case, I will receive it here. Just to know that, maybe I will pass it through a non-resistance, let's say RS.
You're injecting.
I'm injecting a current here. It will go through the bridge and then receive here. I grounded this side. So if current is I will get I into RS voltage here. Yes. Let's say that's equal to Vs. Let's say. Now, what is that I should inject here so that I will get, inject means I know that I is the current, but what is the voltage I should give here so that this current I is flowing through this? That's the next question. Right. So, suppose, let's say, I give this as a feedback to the circuit. I introduce an op-amp there. Minus. Plus terminal, I am giving Vs. Okay. So, if this whole thing is working, right, then this will be Vs. Because this voltage difference should be negligible. No? So, if that is Vs, this is Vs. If this is Vs, there will be a current of I flowing through this. So, that's one way to inject this current I. Actually, it is, now if you look at, this is a amplifier that we have discussed. I think it's a non-inverting amplifier. If you look at non-inverting amplifier, we have given Vs here. And then we had R2 here, R1, this was grounded. So, I think this, let's say this is RS and this is the bridge.
So you're saying that's what you see here.
That's what we see here. So, the current is decided by Vs by Rs. That current flows through this. So, it's a current source actually. Right. We have put this bridge in the feedback such a way that the bridge, through the bridge, current I will be flowing. Now, as we mentioned, since there is current flowing through this, there will be drop here, I into RL1, I into RL2, etc. But same current is flowing through the bridge. So, this voltage will be I into R0. So, what I meant is, irrespective of the variations in RL1 and RL2, because if temperature vary, RL1 and RL2 will vary, or lead wire resistance will change. Still, I will get I into R0.
So that again, sorry?
So, see, this wires, summarize it, this is maybe meters apart.
Let's say it's long.
Let's say 30 meters possible.
So, high resistance.
Yeah. And it's exposed to sunlight. So, morning the some value, lunchtime, it will have maybe 10 or more. Right. So, RL1 and RL2 can change like that. Because this is in the feedback and current is decided by RS only, RS and Vs only.
Okay. Yeah. It doesn't matter.
It doesn't matter. Through the bridge, there will be always I flowing through it.
And it will be R0.
Yes. And I R0 voltage will be available across the bridge.
regardless of power.
Correct. So the bridge is excited with proper voltage of I R naught, and now RL3 and RL4 are not affecting because you are not drawing any current through that.
Because you connected to a
Instrumentation amplifier. Right. There is actually a very small problem or a problem with this method. The full bridge was insensitive to
temperature.
Now, I'm not sure whether that is valid.
Why?
Because the bridge excitation, which is I into R naught,
Or depth resistance might.
R naught will change with respect to pressure. So there will be a term R naught into 1 plus alpha T. So with respect to temperature, this Bs will change, and there will be some error due to that. That's a limitation this method has. Otherwise, this is a nice approach.
So that means, like, I mean, you talked about so many different types of triangulated bridges. So for all of that,
Yeah.
we can use the similar circuit.
We can use this.